Hi everyone, today I'm gonna tell you how to diagnose the COVID-19 by using RT-PCR. Let's begin, and then I think everyone knows how the sample is collected. It is collected by using nasal or an oral swab or a nasopharyngeal swab by using a swab stick, and followed by the collection and the transportation of this sample in a sterile conditions to the labs to perform the PCR test. So after the collection of the sample, the first thing that you have to do is extract the RNA from the swab. So the swab may contain other bacteria that you may have in your nasal cavity and along with the coronavirus if you're positive. And it may also contain your own cells, nucleic acids. So the goal is to extract only coronavirus RNA, but it is not possible. So we have a mixture of nucleic acids. But this real-time PCR works in a way that you can amplify only the coronavirus nucleic acids by using specific primers which binds to the virus RNA and amplify it so that we'll know whether the person is positive or not. So this is the imaginary picture of the real-time PCR. So after extracting, you will load your sample into a real-time PCR machine, which contains RNA extracted nucleic acid, green fluorescent proteins, primers, polymerases, and etc. And then after 2 to 3 hours, it will give the data to the computer so you can read the results and you can know whether the person is positive or not. First thing that happens is conversion of RNA to DNA because PCR cannot be performed on RNA sample and the virus is single-stranded RNA but not DNA. So by using reverse transcriptase polymerase, it is converted to DNA. Then the specific primers which are complementary to the DNA strand will bind to the DNA, and the primers elongates from 5' to 3' direction, and after finishing of production of every single strand of DNA, the fluorophore is released. So the fluorophore signal will tell you how severe the condition is. So the more the signal, the more severe it is. So in a similar way, you can design primers for any viruses and then you can do a PCR and then you can know whether the virus is present in your body or not. It is extremely important to design primers specifically for every single strain of the virus, because if the strain is different and the primers aren't gonna bind to the strand of the DNA and it doesn't amplify or it doesn't show any signal, but if even the person is positive, it won't show the signal because there are not specific primers to that particular strain, so that even the positive person can be shown as a negative COVID-19 person. So you have to be extremely careful in designing primers and choosing it for a particular strain. And then I have made a video on how to do a primers. If you are interested, you can go and check it out in my channel. So okay, then after finishing the PCR, the machine will give you a graph which is between the number of cycles and the fluorescent signal that is produced by every DNA strand. So if the fluorescent signal is high and reaches the threshold cycle in less number of cycles, that means that person is having severe viral load than compared to the person whose signal reached the threshold at higher cycles. And if the person is negative for the COVID-19, there won't be any binding of primers and there won't be any fluorescence signal that is enough to catch up by the PCR and given in the graph. So there won't be any curves if the person is negative, and the curve will reach the threshold soon if the person is having severe viral load infection, and if the person is having moderate, and it takes up to several cycles to show the fluorescent signal. So there are many conditions that has to be taken care of to confirm that the person is 100% COVID negative or positive. Some of them are like the results may get affected by even the storage conditions and the transportation of your sample to the labs, and the techniques or the methods that the personnel is performing the PCR, or there can be many other conditions. So it's better to be careful because you cannot trust the results 100% always. I hope you like this video. If you like it, give it a thumbs up. Thank you.